Hi guys, so today in this video we are going to solve this three sum problem. Okay, so the given the problem statement is like we will be given array numbers. Okay, and we have to return all the triplets which are such that um, they are sum of they sum up to 0. Okay, and condition would be like I is not equal to j, I is not equal to j, and j is not equal to means they should be like and the index should be unique. Okay, and also it should not contain a duplicate triplets. Okay, so to first understand this problem, like how we are going to solve this problem is like suppose this is the array, given array. Okay, so this is this triplets that, like you can see, -1 plus 2 would be 0. Okay, -1 0 and 1 would be 2, but the condition is like this triplet should not repeat again and again. Okay, so this cannot be repeated again in this array. Okay, so how we are going to tackle this problem is like so what we are going to do is so first of what we are going to do is we going to do sort this array. Okay, and after sorting, like what we are going to get is like something this, like you can see -4 -1 -1 0 1 and 2. Okay, so the question is now how we are going to find this triplet. So uh, when you have solved this two sum, okay, the two sum part 2, if and there is a video on my channel, and if you have idea that we were using left pointer and right pointer, right? So what we are going to do here is we are first going to loop over this array. Okay, so uh, this would be our I0. Okay, and on second iteration this would be our I1. Okay, so we will select this element and we will look for the two more elements from the same array where we while when we do the sum of this two more, and it should be equal to 0. So how we are going to do this is like we are going to take a left pointer here. Okay, so left pointer, so this would be left pointer, left point. Okay, and this would be right. Okay, so first we will look for that -4 -1 plus 2 equals to -3. Okay, so that is not equal to 0. Okay, and -3 is something like which is more than sorry, less than 0. Okay, so what we, in case we would do is we would increment this left. Okay, and increment this left and try to uh, increment this left, and we will not decrement this right. Right would be staying the 2, and 4 -4 1 -4 -1, then again 2. So what you encounter is the duplicate. Okay, because already this pattern was tried, like -4 -1 2, which was not equal to 0, right? It was -3. So this pattern is already tried. So what we have encountered here is that the second element also can be duplicate. Okay, so like next we would try for, so we would try to skip this. Okay, skip this part. Okay, so first of all then we will try for -4 0 or 2. Okay, so in this case also we don't have any solution, and then -4 -2 would be -2, okay, which is again less than 0, then we would increment the left and check whether 1 -4 2 would be -1, which is not again, but we are keeping here check whether the left is greater than right or not, okay. So uh, you are so suppose basically we are going to create very unique triplets, okay. So first, for this -4, we tried all the combinations, and whatever we, if in the combinations I'm getting any solution, then we are pushing that triplet to the result, okay. Then we are coming to -1, okay, in the second loop, second iteration, okay. So -1, and then we are trying all the combinations from here to here, okay. So then after that we come here and we see that again it's a duplicate. So we need a unique combination, right? So as we can see, like with the -1 we have tried all this all these elements, okay. Because with the left and right, okay. So again with the right, with the -1, that would be the same case, because we, if there is any combination, we would be getting that combination again and again, okay. So that would be the case. So in that case we should try to skip that, okay. And one more condition we have to take care of, the zeroth. After the 0 has appeared, if our left means like our iteration has gone more than 0, then we need to break the loop. Why? Because after 0 there is very no chance to sum up of the elements to 0, like, because like if suppose our main loop comes to year 1, then we would see 2, or suppose here there was on one more element 3, then summing of them is never possible to 0. So we need to take care of is like first we need a very unique in the first element, okay. Then we need a very unique on the second also, and on the same on the third also, okay. So this triplet ways cannot be repeated again and again in this result, okay, main result. So how we are going to do this is like so first of all what we need to do is sort. First of all we need to create a result array in which we will push the all the triplets, okay. Then what one can do is we would sort this, and after sorting this what we are going to do is we are going to run the loop. I plus plus, okay, we are going to run over this, okay. Then what we are going to do is check whether we are going to first assign a variable a and check whether like should be the element itself, okay, the current element itself, and check whether if a is greater than 0, in that case we need to break. Why break? Because we know that after 0 each combination would not sum up to 0, okay. because all is the because after that all are the positive integers. Okay, so if then what we can do is another condition is like check for like if a equals to so what we are doing here is we are checking whether it is a initial 0 or not, means I is 0 or not. If there is 1 2 3 4, then we need to check whether it is equal to its previous element or not. Okay, the current element is equal to previous or not, because we need to skip it. Why? Because we didn't want any duplicate variable. So we tried this, right? We saw this where we encounter -1 and then we encounter again -1, and we were facing that means the duplicate and triplets were we were getting of to this, right? So then why what we can do is we can create a L, which is which stands for left, and here then what we can do is I plus 1, and let r equals to nums dot length minus 1. Okay, so what happened here is when we created this we are going to loop over this. So we are taking this as a and this is a left, initial left, and this is a right. Okay, so I should be so left should be I plus 1, and exactly number right should be number length minus 1. Okay, so what we are going to do inside this loop is we would check for whether L is less than or R. Okay, if yes, then we would do is check for the sum. How we are going to do is a nums are. Okay, so what we are going to do is we are first going to make a sum and then check whether the sum is greater than 0. If it is greater than 0, then we need to decrement r. Okay, so as you can see, where if our like left and right and plus the a as the sum of greater than 0, then it is understood that like it is understood that it is going we need to decrement the right, because of the sum is going to be sum is somehow greater than 0, so we need to decrement this, right? Okay, else if sum is lesser than 0, then we understood that it's a negative, so still we need to push our pointers to of the left. Okay, then we need to increment this, else else is when sum is equal to 0. Okay, we then can do is we can do result dot push, and we could push this a cell side, right? And then we can l plus plus, and then r plus r minus minus. Similarly, in the main same fashion, what we are doing is we are incrementing the l and decrementing the right. So we are now um, the distance between the left and right, we are decreasing them. Okay, now in this condition what we can check is like while nums l equals to n, l is less than r, then we need to decrement l minus minus. Why? Because we need to check whether after the left was incremented it was equal to previous l or not. Okay, previous left or not. Okay, so this way we avoid the duplication and the duplicate patterns to appear. Like if there is -1, okay, and then means like we have already entered a solution. Okay, then we are incrementing any variable means like left, and which is almost same to the previous one. So possible is that like 4 minus 1 minus 5 means 5 was there. Okay, 5 was there. Okay, so the this solution pattern is again and again repeating itself. Okay, so same way we can do for the right also. So we should not encounter any duplicate left or right. Okay, I am incrementing the left here and right here. Okay, and then what we can do is we would return the result and try to run this. Okay, this solution seems to be very fast, or I don't know. Okay, so the time complexity would be here would be O of n. Okay, O of n square, because like you know this is stand for n log n, and plus there is one loop, and inside there is one loop. Okay, and this loop is not every time going to be these two loops are not going to be every time invoked, right? Space complexity would be like O of n only. Okay, so guys, I hope I was able to make you understand this problem. It's little bit complicated to understand and make someone else also understand. Okay, so after practicing it you will know that what I was trying to explain. Okay.